velocity in meters per second, and this is time. Now, you can choose to put your axis at the top or the bottom or the middle. Out of habit, I always put it in the middle. But what we've got is we have an initial point is at 10. So if we go 2, 4, 6, 8, 10. So I start here, and here's my 0, and I have to get to, we said 10.2 seconds. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So by the time I get over here, I'm going to be at 0 velocity. The equation of this line is going to be y, which is my final velocity, equals v initial, which is 10, plus negative 9.8 t. So y equals negative 9.8x plus 10. That's the equation of my trend line. Okay, let's try another one. Ben plans to go hang gliding. He steps off a 500-meter high cliff and remembers that he forgot to bring the hang glider. How long before he is crushed in the rocks below? Okay, let me explain why this is so sadistic. One of my students many years ago made this question because I had them making up questions, and I don't know, I just never got rid of it. So that's probably on me. I'm sorry if that's gross. So he starts up here. He's got zero velocity. He's at 500 meters high. Time equals 0. When he gets down here, he's at the bottom. Time is greater than 0, and that's what we're looking for. And the final velocity is something greater than 0. Here's my y-axis. We're increasing speed downward. Acceleration, as always, is negative 9.8 meters per second squared. Free body diagram. Those are all that's all my setup. You can do this only using kinematics because we're trying to find time, and law of conservation of energy doesn't allow you to have time in it. So that's this equation. That's negative 500 because I'm moving down. It's final position minus initial position. This is 0. Negative 500 equals negative 4.9 t squared. This will be positive 102 is t squared. So this is 10.1 seconds. So now to sketch position time graph. Now so this is going to be similar to the previous one. This is position. The nice thing about Freefall is that, they're so similar to each other. There's only a handful of options. So we are moving down. That's negative velocity. We are increasing speed. So remember, on a position versus time graph, slope is velocity. Therefore, increasing velocity means increasing slope. And we're moving down, we have to have negative velocities, therefore negative slope. That means it's going to look like that. It's got a negative slope, and it's increasing its slope as time goes on. My initial velocity, my initial position up here is 500 meters, right? Down here is 0. The total time here is going to be 10.1 seconds. Here's 0. The equation of the line. So this is our theory, right? This is 0 because initial velocity is 0. So we're going to have y equals 1/2 of negative 9.8 is negative 4.9, and time is on the x-axis, so it's x squared. So this is the equation of my trend line. Okay, velocity versus time. Oops. The slope of a velocity versus time graph is acceleration. Right, since this is free fall, acceleration must be negative 9.8 meters per second squared. Therefore, the slope must be negative 9.8. So we're going to have a negative slope. We're also moving down, so we have to have negative velocities. That applies also. We're starting at rest, and so we're going to move down with a negative slope. After 10.1 seconds, let's see, my final velocity will be a negative 99 meters per second, which is crazy, right? So that's 99 right down there, where you get to there. And that's pretty much it for this one, right? Okay, last one. Ball is dropped from a 50-meter high cliff. Dropped means velocity 0. Here's my initial position, initial time. At the end, velocity is greater than 0, y equals 0, time is greater than 0. Acceleration is negative 9.8. We're moving down, increasing speed. We've got only the force of gravity. How long, that means we want to know the time. That's what we're looking for. So we're going to do delta d equals v initial t plus 1/2 at squared. So it's negative 50 because I'm moving down, 0 times time. So you get 50 divided by 4.9 and take the square root. You get 3.2 seconds equals time. And let's do the graphing again. It's going to look pretty much exactly the same as the previous one, except the axis is going to be different. This will be 50 this time. And the time is going to go up to, what did we just say, 3.2 seconds. Hello.
I'm so sorry.
It's okay.
I have a question. I wasn't here for the last. I only have like the video.
Mm-hmm.
So what should I do to like?
But
submit?
you have to just finish the analysis. That's
And
all.
how do I, like-
We didn't really spend a lot of time on it either.
Okay. So what do I do with like the video?
What do you mean?
Like, should I just like?
Oh, you have to upload it to Capstone and you have to do the tracking.
Okay.
Okay, and you make a VT graph,
Okay.
and get the slope of it off the capstone.
Is it just like through about feedback, or do we have to print it or something?
No, don't print it. Just put it on Get Feedback. Yeah. Thank you.
Of course.
How was your exam?
It was really good.
Good. All right. The rationale for this is going to be exactly the same, right? So like once you know how to do one free fall graph interpretation like this, like they're pretty much all the same. So, you know, you got to tailor it a little bit, right? So we're still moving downwards here. So we still have a negative slope, which is why I drew it like that. We still have, we still say on a position versus time graph, the slope is velocity. Increasing velocity means increasing slope. We still have the same equation of the trend line because acceleration is not changing. And initial velocity is still 0, so there is no term in the beginning, right? This is still 0. Now, if I threw the ball down, then I'd have another term, but I don't. And therefore, the velocity versus time graph is also going to be, did I label this? No, I didn't label this. The velocity time graph too. You have your initial velocity is 0. We're moving downward like this. It's going to be y equals negative 9.8 x, because your initial velocity is 0. Yeah, I forgot to write that here. You see, it's going to be the same thing because the acceleration is a constant, so it can't change. Just want to straighten out my axis here. The other thing you could do is find out what is the final velocity. So if you know that this is 0, negative 9.8, and this is 3.2, then you can just quickly find out that your final velocity is negative 31.3, and you could put that on your axis. So you could label that, and you can label this as 3.2 seconds. And this way you have some reference values that'll get you to advance if that's what you're looking for. Otherwise, you can continue doing what we were doing before and just be like, oh, I'm going to do like V1, T1, and you can do, you know, I'm going to do T2 and V2. Like that is fine for placeholders, or you could just plug it into the equation and get the actual values. So now your job is to do the independent practice. Hopefully these examples will help you get there.